Today we will be talking about L'Hopital's rule. Let's start by looking at very simple example. We have limit as x approaches 0, sin x divided by x. Normally when finding the limit, you would simplify and cancel to find the limit. However, in cases like this, we cannot simplify any further, and if we sub 0 in, we will get the indeterminate form of 0 over 0, and the denominator cannot be 0 as the function is not defined or does not exist at that value. So to solve a limit like this, we use L'Hopital's rule, which is basically finding the derivative of the numerator and denominator, which will give us a function that when we sub in the x value, it will give us the limit and not an indeterminate form of 0 over 0 or infinite over infinite. Note that L'Hopital's rule only works on a quotient function. So if you have a product or a power, you must convert it to a quotient to use L'Hopital's rule. So the rule is pretty simple. Find the derivative of the top and the derivative of the bottom. Always indicate that you use L'Hopital's rule by writing LHR beside where you used it, and then sub in the x value to find the limit. In this case, the derivative of sin x is cosine x, and the derivative of x is 1, so we get cosine x. When we sub in 0, cosine 0 is 1. Now we have limit as x approaches 0, e to the x minus 1 minus x minus half times x squared, divided by x cubed. As usual, the first step is to always sub in the x value and see whether you get a limit or an indeterminate form. If you get the limit, then you're done, but in this case we got 0 over 0, so an indeterminate form. Check if you can simplify first. In this, we cannot, and the function is a quotient, so we may use L'Hopital's rule to find the limit. So we get that limit as x approaches 0 is equal to e to the x minus 1 minus x divided by 3x squared, and we indicate that we used L'Hopital's rule by writing LHR. Now if we sub I0, we will still get 0 over 0, so we have to keep using L'Hopital's rule until we get a limit and not an indeterminate form. So we get limit as x approaches 0 e to the x minus 1 over 6x. Looks like we get an indeterminate form. So we do L'Hopital's rule one more time, and we get that limit as x approaches 0 e to the x over 6. Now we sub in 0, and we get 1 over 6, which is our limit. The next example is limit as x approaches infinity square root of x divided by ln x. Let's analyze the behavior of the y as x approaches infinity. So for the square root of x, as x approaches infinity, y is also approaching infinity, and same applies for ln x. This means that if we sub in a large number or infinity into x, we get an indeterminate form of infinity over infinity, so we must use L'Hopital's rule to find the actual limit. Before we use L'Hopital's rule, let's convert the square root of x to the power of half, so it becomes easier to differentiate. Now we differentiate the top and bottom to get that limit as x approaches infinity 1 over 2 times x to the power of negative half divided by 1 over x, and indicate that we use L'Hopital's rule. Then we simplify to get 1 over 2 times square root of x divided by 1 over x. Then to divide fractions we use the keep switch flip rule, and we get 1 divided by 2 times the square root of x times x. This will equal to limit as x approaches infinity x divided by 2 times the square root of x. Now we have to do L'Hopital's rule again, or we will still get an indeterminate form. We get 1 over x to the power of negative half, which when simplified is equal to limit as x approaches infinity the square root of x. Now we analyze the function and we see that as x approaches infinity, y approaches infinity, which means the limit does not exist and it just keeps going to infinity. The next example is limit as x approaches 1 from the right side, sin pi x divided by the square root of x minus 1. Obviously, if we sub 1 into the equation, we will get the indeterminate form of 0 over 0, which indicates that we have to use L'Hopital's rule. First, convert the square root of x minus 1 to x minus 1 to the power of half. Now we can differentiate and we get cos pi x times pi divided by 1 over 2 times x minus 1 to the power of negative half times 1. We simplify to get limit as x approaches from the right side, pi times cos pi x divided by 1 over 2 times x minus 1 to the power of negative half, which will equal to limit as x approaches 1 from the right side, pi times cos pi x times the square root of x minus 1 divided by 2. Now that we have it simplified, we sub 1 in for x, and we get 0 over 2, which means the limit is 0. Let's look at one more example. We have limit as x approaches 0, 1 minus 2x to the power of 1 over x. This is a power example, and if you sub in 0, you will get 1 to the power of 1 over 0, which does not exist, and therefore this is an indeterminate form. So in this case, our first step is to convert this power function to a quotient, or else we'll not be able to use L'Hopital's rule. To do so, our first step will be to take the function from the limit and make it equal to y. Then we take the natural logarithm of both sides. To get that ln y is equal to ln q minus 2x to the power of 1 over x. Now we bring the 1 over x, which is a power beside the ln 1 minus 2x. This is one of the logarithm laws. Now if we simplify, we get that ln y is equal to ln 1 minus 2x divided by x. This will be our quotient function. The next step is put this quotient function back in the limit to get limit as x approaches 0, ln 1 minus 2x divided by x. Then use L'Hopital's rule to get that limit as x approaches 0, 1 divided by 1 minus 2x times negative 2 divided by 1, which simplifies to limit as x approaches 0, minus 2 divided by 1 minus 2x. Now sub in 0 to get minus 2. However, we are not done yet, because notice that its ln y is equal to negative 2. So we have to fully isolate y, which will give us e to the power of negative 2.